This last little bit is just some step-by-step work through putting it all together. I'm going to take you through the 4-step process for constructing a confidence interval for a population mean, as well as talking about the how we can determine the n that we would need to have a certain level of confidence with a specified margin of error. So if you want to keep your interval at a certain tightness, how big of a sample size would you need to have? Just a quick reminder about how population means are going to ask you to look at a couple of new things. One is we've been using z-scores for a really long time, but because when we take the standard deviation of a sample, the distribution of that standard deviation is not normal, it's in a t distribution, then we have to look at two pieces when we are calculating the margin of error. To get the t-star, you've got to pay attention to both the confidence level percentage as well as what's called the degrees of freedom. So that degrees of freedom, once again, is just, the n minus 1. So we're going to go through the whole process here. So environmentalists, government officials, and vehicle manufacturers are all interested in studying the auto exhaust emissions produced by motor vehicles. The major pollutants in auto exhaust from gasoline engines are hydrocarbons, carbon monoxide, and nitrogen oxides. Researchers collected data on the NOx level in grams per mile for a random sample of 40 light-duty engines of the same type. The mean NOx reading was 1.267 and the standard deviation was 0.0032. So we're being asked to construct and interpret a 95% confidence interval for the mean amount of NOx emitted for light-duty engines. So first we're like, what are you being asked to do? Okay, confidence interval. Then we look for our clues in the problem to tell us whether that confidence interval has to do with a proportion or has to do with a mean, because we're talking about two different equations. One would be p hat plus or minus z star square root of p, 1 minus p all over n, or the mean, which would be x bar plus or minus, get our margin error from our t star, and whoops, I goofed up. Then we're just going to have the standard deviation of x over the square root of n. So we're looking at this, and sure enough, this one tells us that we're talking about a mean reading, and we already know from the sample what the standard deviation is, so we have enough information to go ahead and move forward. So whenever we're doing a large problem, just throwing the calculations on the paper is not going to be enough. You're going to have to state what we're trying to do. You're going to tell them what the plan is, including all of the conditions, and that those conditions have been met. In our case, we're dealing with a mean, so we have to have random taken care of, 10% taken care of, and large sample. And then we're going to go ahead and do the math, and then we're going to conclude. And with a confidence interval, that conclusion will just be in that we are blah, blah, blah % confident that this interval, that whole process. So whenever we're concluding or answering the question with a confidence interval, it's going to have that template. So here we're going to go. So we want to estimate, here's our state, we want to estimate the true mean amount of population mean of NOx emitted by all light-duty vehicles of this type at a 95% confidence level. So the plan is, if the conditions are met, then we're going to go ahead and use a one sample t-interval, and we know we're going to need that because it's a mean, and we only have the standard deviation from the sample. The three things that we need to meet are random, it said random sample given to you, 10% of the population are not being represented, so we're good. 10 times 40 is going to be 400 light-duty vehicles. There's plenty more than that on the road. And then in terms of the large sample, first thing we're going to look at is, do we know if the population distribution is normal? We don't know that, so it's not a go yet. But the sample size is large enough that we can go ahead and be safe to use a t-distribution. So our state and our plan's taken care of. Now we're going to go ahead and do it. The information that we've been given, we're given the mean, we're given the standard deviation. We know that n is 40. So our DF is going to be 39. There is no row attached to 39, and so we're going to use the closest but lower to allow us to ensure that we got that 95% that we want. So our T star is going to be at the 95th level right here, 2.042. By the way, you do need to understand what this top thing tells you. The T, and I don't know how to draw a T with a DF of 30, but just imagine that this is a T distribution. This 0.025 is that probability on the tail for a 95% confidence level, and we're going to need to understand that as well. So here where we throw everything in. Here's our mean, plus or minus. This is our T star, our X bar, our N. We're going to go ahead and calculate that, and then we write the interval in this form when we're finishing the problem. So here's margin of error form, here's interval form written with the notation that they use, and then we're going to conclude. We are 95% confident that the interval from 1.599 to 1.3751 captures the true mean of the nitrogen oxides emitted by this type of light-duty engine. Sometimes you will be asked to then look at another piece by saying that this company is saying that their nitrogen oxide is at 1.0. And what does this confidence level tell you? Well, if they're saying that their nitrogen oxide levels are at 1.0, it's probably not a valid claim, because we're 95% confident that the true value has been captured by our interval. So choosing a sample size, it's possible that you would want to create an experiment, the analysis of an experiment or a survey itself that has a desired margin of error. You don't want it to be too wide or too wide specifically. And we know that when we go from a 95% confidence interval, for example, to a 99, that is the worst picture ever, the margin of error is going to increase. So one of the ways to shrink the margin of error is to have a lower confidence level. But that's not necessarily what you want to do. You want to have a fairly high confidence level. So the other way to affect the margin of error is to increase the n, because the higher number of n is going to, remember you're taking the square root of n every time, the higher number n is going to shrink that margin of error, make it a smaller thing. But so you can just plug in everything you've got and do an algebraic set of steps and get yourself what n has to be to get within a certain margin of error. However, here's where means are once again cranky. So we went to all of this trouble to find out that it has to be T star and S of x and square root of n whenever we're making our confidence interval. But if we're going to find a sample size, we're going to probably have to have some information from the previous, some previous studies on similar things. So you will have the population standard deviation, because it's impossible to use this for this kind of calculation, because you can't know the sample standard deviation without knowing the n, and if you don't have the n, you can't find the degrees of freedom. So this is a useless tool if you're trying to figure out the standard deviation. That is not what I wanted to say. It's a useless tool if you're trying to do some calculations to figure out what n is going to be. So very often when you're just determining, hello, when you're creating a sample, you want to make sure that you're within a margin of error. And remember, margins of error come from two things: the confidence level, and then also the n size, because the higher the n size, the smaller the margin. So we're going to go through a process of doing this, and so here's our, you can skip this page if you know how to do the algebra, just scooch. So we have some work. We need to get the n by itself, and we need to get the numbers on the other side. And so the easiest thing to do is to go ahead and multiply. In this case, all you have to do is multiply both sides by the square root of n. So when you do that, you end up with, on this side, 1.96 times 5, and on this side, the square root of n, because the square root of n will cancel this one out. And then all you have to do is do a little math. 1.96 times 5